This lesson shows how to graph rational functions. In previous lessons, you learned one way to write the general form of a rational function, y equals a over x minus b plus c. In this form, x equaled b is a vertical asymptote. A vertical asymptote, or VA, is a vertical line through x equals b on the x-axis. Near a VA, the graph of the function curves up or down towards the line, getting close but never touching. Y equals c is a horizontal asymptote for the function. A horizontal asymptote, or HA, is a horizontal line through y equals c on the y-axis. A horizontal asymptote describes how the graph of the function behaves away from the VA, off the edge of the graph to the left and to the right. The graph of the function curves towards the HA, getting close but never touching. Notice the graph of a rational function always has two branches that are not connected. That's because the function is not defined at x equals b, the location of the vertical asymptote. When x is equal to b, the denominator of the function equals 0, and division by 0 is not defined. So there's a gap in the graph and the domain of the function, which is called a discontinuity. Also notice on one side of the VA, the graph can either be above or below the HA, but can't be both, above and below, because then it would fail the vertical line test, and it wouldn't be a function. So for this type of rational function, there are two possible arrangements of the graph. The right-hand branch of the graph can be above the HA and the other branch below. Or it can be reversed, with the left-hand branch of the function above the HA and the other branch below. For this type of rational function, it's not possible for both branches of the graph to be above the HA, or to have both branches below the HA. Finally, this equation represents only one type, class, or group of rational function. There are many other variations, which you'll learn about in a further course. So going back to the beginning, to graph a rational function, first graph the vertical asymptote x equals b, and then the horizontal asymptote y equals c. Then calculate at least one point on the right side of the VA. If the point is above the HA, the right-hand branch of the graph must look like this. If the point is below the HA, the right-hand branch of the function looks like this. Then calculate a point on the left side of the VA, and the left-hand branch of the function will either be above or below the HA. Once you have at least one point on either side of the VA, you can calculate one or two more points, and then sketch a graph of the function. So here's an example of the whole process. For this rational function, the VA is x equals 2. and the HA is y equals -1. On the right side, the easiest point to calculate is a point 1 unit away from the VA at x equals 3. So substitute x equals 3 into the equation. You get y equals 3 over 1 minus 1, which is y equals 2. So graph a point at 3, 2. Then calculate a point 1 unit to the left of the VA at x equals 1. Substitute x equals 1 into the equation. You get y equals 3 over -1 minus 1, which is y equals -4. So graph a point at 1, -4. Then calculate 1 or 2 more points on the right and on the left. Draw a curve through the points, and you have the graph of the function. Be sure to sketch the graph curving towards the asymptotes, close but not touching. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.